All right, so this is exercise number 5, simple harmonic motion. And you can see I've got my thing duct taped up again, one of my bar magnets, and it's facing the north approximately. You can see it's moving back and forth. What I'm going to do is I've set it up already, set up the solenoid, align it with the magnetic field, turn the current on, so I already checked it out. So then what I want to do is deflect the magnet and let it go. The compass will oscillate. Count the time for 5 oscillations. So an oscillation, remember what we did last semester, we have to count an entire one. So we start at 0, 0, 1, that's 1 oscillation. Okay, so I have a timer right next to me. You can't see it right now, but I'm going to start it. And if you want to bring your cell phones out, you can do. I'm just using my cell phone because I forgot the timer from work. So what I'm going to do is start it when it goes all the way to the left. Now. 1, 2, 3, 4, 5. All right, you can see that it's oscillating, and it's simple harmonic motion because it's repeating itself. Now let's go see how much time it took. So for those 5 oscillations, 21.13 seconds. And that's with 0 current applied. It's still oscillating because of the magnetic field of the Earth. This acts like a dipole. A dipole, if it's an electric dipole in an electric field, it'll rotate around its center of mass. Magnetic dipoles will rotate about their center of mass in a magnetic field. And this is a uniform magnetic field we're the Earth's magnetic field. And what we're going to do now is we're going to impose an extra magnetic field on top of it to see if I can get it to go faster. Because the stronger the magnetic field, the faster the harmonic motion will be. So that was your first data point for this one. It's a little bit tedious because we have to go up to 3 amps. What I'm now going to do is turn on the power. I've got it down to 0 right now. Turn on the power supply. One thing about the setup is you notice that it's slightly off. Unfortunately, that alligator clip, remember how that's it's made out of steel, so it's attracting my little thing slightly. But it still should work. And what we're going to do now is count the number of oscillations when I move it up to 0.5 amps. So let's move up the voltage. Oops. Oh my God, that was way too much. Okay. 0.2, 3, 0.4. Come on, go up. I knew it. I was going to overshoot it. All right. Well, that's good enough. All right. So I'm at 0.5 amps, and you can see, wow, it looks like it's going a little faster. So I'm going to turn back on my thing, reset it. Okay, so let's do 5 oscillations. 0, 1, 2, 3, 4, 5. All righty. So it's a little lower, 20.42 seconds. So again, you might have seen the amps was 0 and 1.4 volts. That's for the AC setting. So remember, we're using DC. So I've got it set on it went down a little bit, 0.5 amps approximately. So ignore the right-hand side. It's producing something, but we don't really need it right now. So I'm going to reset my timer. So that was for half an amp. Reset. Oops. Pause. Reset. Now I'm going to go up to 1 amp, give or take. Oh, that's really close. Oh, look at that. And there it's oscillating. So let's do it again. Or start when it's at the left. So ready? 0, 1, 2, 3, All right. So that time, 16.19. 16.19. Now it's not going down linearly because it's an inverse relationship, but you should see the time going down. It's going to go down more than it should if it was linearly. If we're doing this for the sophomore level lab, I would have you plot it out, and we're finding the constant from here. Okay, I'm going to reset my time, then go back to go up to 1.5 amps, sorry. Oops, I went past it. And we just continue on until we get to 3 amps, so it's slightly tedious, but all right. 1.5 amps. And let me actually move it a little bit. What I don't want it to do, okay, I guess it's okay. I don't want it to go like, I just want it to rotate. I don't want it to translate at the same time. Okay, ready? Start. 1, 2, 3, 4, and 5. All right, so you can see it's getting significantly faster, 13.2 seconds. So indeed, when I increase the magnetic field via my solenoid, I can get the thing to rotate faster. That's because the restoring force is higher. It's like having a stiffer spring. So let's continue on. I got 1.5 amps, so I'll go up to 2 amps. Wow, that was like almost perfect the first time around. Just move it down a tiny bit. Oh. Ah. All right. I'm just going to try and get as close as I can. That's approximately 2 amps. We don't really need a lot of precision in here. Okay, so again, I'm going to start again. Ready? Start. 1, 2, 3, 4, and 5. All right, so this time it only took 11.30 seconds. 11.30 seconds. That was for 2 amps. All right, we have 2 more data points to take. Oh, move this up this way. So let's move it up to 2.5 amps. So again, the higher the magnetic field, the faster it's rotating because the torque is higher. There's a torque acting on this thing. All right, so I gotta reset my lot. Okay, is everybody ready? So ready, start. 1, 2, 3, 4, 5. 10.15 seconds. 10.15 seconds. My reaction time is, I was getting a little into it. So our last data point, we go up to 3 amps. Oh, okay, there. Wow. I'm just going to leave there. 3.01 amps. That's close enough. Reset my timer, and we should be all ready to start. So ready, 0, 1, 2, 3, 4, and 5. And we have got 8.96 seconds. 8.96 seconds at 3 amps. Okay, so that is, we filled up the data table. All right, so I think 5 oscillations, repeat, go to 3 amps. Find the period dividing by 5. What do you notice of the period as the current in the solenoid is increasing? So you do that on your own. You can go and fill out the rest of the questions that they have in there. So that's exercise number 5. Now we're going to go on to exercise number 6, Faraday's law.